I welcome you to this short presentation for Ethicum 2020 titled Ethical Issues of E-Infrastructures, What Are They and How Can They Be Addressed? Authors are Damien Eke, Simisola Akintoye, William Knight, George Ugo, and Ben Stahl. All authors from De Montfort University, Leicester, United Kingdom, and all working for the EU Human Brain Project. As the title suggests, in this paper, we provide a general overview of the ethical issues associated with e-infrastructures and present a practical way of thinking about these ethical issues through ethics by design. This was done based on non-empirical critical reflection on literature and personal observations and experiences of the authors as members of the ethics support team of the EU Human Brain Project, building a neuroscience e-infrastructure called European Brain Research Infrastructure, eBrains. According to the Director General of for Research and Innovation of the European Commission, research infrastructures are facilities that provide resources and services for research communities to conduct research and foster innovation. In our increasingly digitized world, these facilities are becoming more electronic with ICT-based resources interconnecting computer science and specific research disciplines. These are called e-infrastructures, combining digital technology, computational resources to support research collaborations, creating new virtual research communities that share, federate, access scientific tools and resources. They are defined in this paper as computing facilities and electronic resources that facilitate research and innovation, which are differentiated from other research infrastructures due to the ability to provide digital services, resources, and tools for scientific research. The international ecosystem of e-infrastructure is extensive and different in that they have evolved along different geographic, disciplinary, and application dimensions. These often disparate e-infrastructures aim to provide open, flexible, and competitive national and international services to advance scientific collaborations. In addition to enabling collaborations across disciplines and national boundaries, these ICT-based, data-driven, and computer-intensive infrastructures are also being established to promote scientific reproducibility, improve research efficiency, creativity, and rigor. According to the European E-Infrastructure Reflection Group, EIRG, the pan-European e-infrastructure landscape includes networking infrastructure, supercomputing infrastructure, cloud infrastructure, and data infrastructure. These infrastructures empower researchers to explore scientific questions in different ways and involve a lot of complex interrelationships between researchers, the technology organizations, networks, and variety of human data and animal data. The technical and social dynamics of these interrelationships present a number of ethical, legal, and social risks because persons and data are involved. Some of these concerns can generally be associated with all EE infrastructures or indeed all research infrastructures, but some are peculiar to certain infrastructures. Looking at this diagram, you can see that there are common EE infrastructure concerns, which include the dual use, security, data protection, and privacy, opportunity cost, digital divide, and issues of misuse. For many e-infrastructure, concerns are mainly related to data sharing, security, access, and interoperability. While these e-infrastructures attempt to foster scientific discoveries through sharing of data, there is also the need to ensure data subjects' privacy and confidentiality. These are fundamental ethical legal requirements for research collaboration in any research involving human data. A virtual platform hosting terabytes of human data surely amplifies concerns related to privacy and data protection. Identifiable research data-related issues include informed consent issues, incidental findings, and possibilities of positive re-identification. Fundamentally, these raise questions of autonomy and the practical questions of accountability and whose responsibility it is to address these issues. They also raise technical question of how to protect the rights of the research subjects in the face of changing landscape of technology, making it difficult to achieve effective de-identification or anonymization of human datasets. There are also the critical issue of data controllership. Who owns and controls the data? A clear identification of the data controller has important influence on the sharing of data as well as the apportionment of liabilities in cases of data breach. E-infrastructures involve data processing at different levels and by multiple institutions, which are sometimes located in different countries with different data protection provisions. Determining the data controller and data processor rules at the various levels of the research grid becomes very complicated. The collaborative nature of the e-infrastructure ecosystem also complicates the issue of copyright and intellectual property rights. For instance, the collaborative work in or for e-infrastructure can lead to the development of a bespoke software with the possibility that no license or intellectual property agreement was made prior to the development, as was observed by the 2003 EIRG Task Force report on legal issues. Determining the owners of the intellectual property and what the software can be used for, especially when state funds are involved, become a critical challenge. There are also complex ethical issues that are associated with supercomputing infrastructures. Addressing them at ethics of HPC, Lawson et al. Identified three major ethical issues surrounding the use and application of HPCs. These include misuse, inequality, and environmental concerns. These issues are not trivial and contribute to the wider discourse on what is referred to in this paper as e-infrastructure ethics, which means a set of moral principles and standards that should govern the use of e-infrastructures. But how can these issues be addressed? Drawing from the literature on technology ethics and design thinking, we're arguing that the concept of ethics by design as a form of value-sensitive design provides a robust framework for ethical and legal consideration of risk in the development and application of research e-infrastructures. It is evident that in the design of e-infrastructures is fraught with the need to make ethically responsible choices that can shape the application of its tools, resources, and services. There's a need for e-infrastructure developers to appreciate the responsibility they have in addressing ethical problems exhibited by this innovation. The complex relationships within the e-infrastructure ecosystem present critical challenges, and the integration and implementation of relevant principles will require the collaboration of stakeholders involved in e-infrastructures. It will involve the mixture of technical, social, and legal mechanisms that provide solutions to both identifiable and unanticipated problems. It requires ethics by design. E-infrastructures create imbalances between those who have access and those who do not, those whose interests are addressed and those who lack representation, threatening the privacy rights of data subjects. A responsible e-infrastructure innovation should therefore consider the interests of many sections of the society, creating systems that will provide solutions with inclusive values. It requires meaningful engagement and reflection that can align the design with societal values. That is why RRI can provide a practical tool of implementing ethics by design for e-infrastructures. RRI can equip e-infrastructure developers with the knowledge of relevant values and principles through reflective and inclusive activities and practical ways of putting action into practice. It can provide a way of ensuring that ethics is an essential component of the core functionality of e-infrastructures or is integral to the system without diminishing its scientific purposes, especially the version endorsed by the UK Engineering and Physical Sciences Research Council, which adopts a reflective process of anticipation, reflection, engagement, and action, otherwise called the AREA framework. In conclusion, we have to note that the effectiveness of this approach in the design of EU infrastructure is yet to be tested. But as members of the Ethics and Society sub-project of the EU Human Brain Project, HPP, who is working towards the development of international neuroscience infrastructure, we have an opportunity to test the implication of applying RRI as an ethics by design tool in the development and application of an e-infrastructure. But how this can be done is something that we're still developing. Thanks.